Collecting like terms. So we're going to be discussing collecting like terms, and the first question, of course, is what is a term? So the parts of a term, we have a number in front, and the fancy math name for that is the coefficient. And then over here, we have this part over here, and that's the variable part. And that whole thing together, all this is a term. And then we have another term. So this, for that one, this would be the coefficient. This whole thing would be the variable part, the thing with the letters. And that entire thing would be another term. Which kind of leads us to the idea that a term is going to be also something that's separated by a plus or a minus that's kind of not in the term box. So for example, how many terms do we have here? So what we know is that this is a term, this is a term, and this is a term. So we have a total of 3 terms. This one over here, that's a term. There's an open plus or minus. This is a term, open plus or minus. That's a term, 3 terms. This thing here, x squared y over 7, all this is a term, minus. This thing is a term. This one only has 2 terms. And over here, last but not least, this one over here, now there is a minus, but the minus is not actually open. It has to be totally open. So in fact, that's a term, that's a term, that's a term, and that's a term, which means we have a total of 4 terms. Now we're going to talk about something that is called like terms. So like terms are defined as having the same variable and the same exponents for each variable. So each variable has to have the same exponents. So if we look over here and I say which, let's put some pluses, here we have 3 terms, and I want to know which of these terms are like. So which ones have the same variable and the same exponents? Well, these both have x, but that's an x and that's an x squared. The coefficients are the same, but that doesn't really matter. So what we have is this and this have the same variable, the same exponents. So these things are like terms. Okay, so take a second here and try to figure out which of these are like terms. I would pause the video and try to do that. I'm going to go straight into the answer right now though. So what we have is for x, that's a variable x, and that's going to be like with this one over here. You may have thought that it was like with this one, but it's not. That's divided by x. So that's not a like term. 3y. Y. Oh, minus 8. The fact that it's plus or minus doesn't really change anything. So 3y and negative 8y are still like terms. 17. This has no variables, so this is going to be actually a like term with something that also has no variables, which in this case will be this one over here. Okay. 7x squared, that's going to be the same as x squared, so these two are like terms. I think I've kind of run out of colors here. xy, 17xy. You may think that there's nothing that's a like term with that over it, but the order actually doesn't matter when you're, because all these things are multiplied. It's 17 times x times y, and there's a property in math that when you multiply things, order doesn't matter. So xy and yx are actually still x. They're both xy. So these guys are also like terms. There's a lot of like terms in this stuff, right? 13x squared y. Now this one looks kind of the same, but here the squared is on the x, here the squared is on the y. So these two are not actually like terms. Here the squared's on the x, but there's also a squared on the y, also not like terms. This one, you have the squared is on the x, there's no square on the y, and these guys are like terms. I think that might be it. I don't think there's anything that's like with those. Nothing with that, nothing with that, nothing with that. And those are all the pairs of like terms.